Yeah, baby.
All right, we've had this title and purpose down several times. This is the third class, and you wrote down, do plants need light to make chlorophyll, on your experimental worksheet. Hold up your experimental worksheet right now. Remember, all this is the correct one. This is the one that says experimental worksheet right on the top. And the purpose question right there is, what do I want to find out? Do plants need light to make chlorophyll? You should have that in front of you right now. Thank you for being prepared for class. It's a girl thing. You know. All right, just put that down for a moment and look up. Go. Good. Tape it down. Don't know if you've been paying attention to this. These are the plants that we have here that have been growing in direct light. These are radishes. You grew them last year and the year before. This is what healthy radishes look like. Okay? Okay? Okay. Then over here, we have the radishes. That's a radish root. These are the radishes that were growing in the dark. They're grown in the box. And what we're going to do is take the box off, and I think right off the bat, you'll be able to know, do plants need light to make chlorophyll as soon as we see these dark plants. Okay? One, two, three. So the question would be, if these are the light group of plants and these are the dark group of plants, raise your hand if you can tell there's a difference between the two groups of plants. Okay? Hands down. Going back to the pizza method of measuring area. Raise your hand if you think the light group of plants has bigger leaves than the darker group of plants. Okay, hands down. So just right off the bat, before we even get into measurement here, how many people think that the plants do need light to make chlorophyll? I think that's a reasonably good assumption. Now we're going to find out exactly how much. Okay? And here's what we're going to do. You have a grid, which is a bunch of boxes. Right? And what I'm going to do here is, your grid has many more boxes in this, but let's just do this. In your one square, all I want you to do is write down 1 centimeter. And we're just going to say that is the length of one of the sides. So just label one of the sides of the smaller box with 1 centimeter. Now, does anybody remember what the area of the inside of this little box was? Oh! We spent a whole fair amount of time doing this. Oof. It's 1 centimeter squared. So put a 1 centimeter squared inside the box. So that's just to remind us that the length of one side of the small box is 1 centimeter. The area inside the little box is 1 centimeter squared. Okay? Okay, you got that done? You have that in your book already? Boss, just crack that whip back here, make sure. Okay. This is how we're going to play the game. The boss and I, everybody point to the boss. Good, you got that right. The boss and I are going to come around, and we're going to pluck the leaves right off the little plants. We're going to drop them down on the worksheet you have. You're going to tape the large leaves down where it says, or I'm sorry, you're going to tape the leaves from the plants from the light group on the squares where it says light. And then I'll be bringing around the leaves from the plants that are the no light, and you'll tape it down on that side. Okay? Okay? Here's how we're going to play the game. Let's just say that you have a leaf that covers this much of one of the squares. How much of that square is covered by the leaf? Now, remember we did this last time? You can give me the answer in cents. So imagine there was 100 pennies inside that square. How many pennies are being covered? Or you can convert the pennies into dollars with a decimal and a dollar sign. Right? Or think of percent. Pennies are really percent. That's where cent, percent, get it? Okay. So talk to the kid next to you. I'm going to pick on one of you. Everybody has to have an answer ready to go. If you don't have an answer, you got a problem. Tuck, 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 tuck. You guys all talking over there? You all got a good answer? Oh, I like how you said that, I think.
I think it's 1.5. So not 1.5.
Well, wait, why can it not be 1.5?
Because if 1.5 is full square, then it'd be cut in say like
It would be going over 2. You know it can't be more than 1.
yeah.
So it can't be 1.5. That's good. Now,
I said cents is what I found.
15 cents is what
15 or 15?
That covers almost the whole thing. The whole thing would be
Let me do this
I
now.
think it's 0.05.
Yeah.
This is the leaf here inside the heart shape.
Yeah.
So I want to know how much is covered. I think you gave me the answer of what's not covered, which is a good way of doing it.
I
But
think it's
how much? So we could do this. You could say the area, oh, I don't like that. Let's go back to black. We could say the area was equal to, let's just say 90%. All right? All right. We could say the area is equal to 90 cents out of 100. That's what 90% is. So if there was 100 pennies in that box, 90 would be covered. Then we could do this. Area is equal to $0.90. Can I do that? Well, yeah, that's how you do it. But then we also said this. Then the area then would be then equal to 0.90 centimeters squared. And boys and girls, if you can do your math thinking in money, it's a lot better. Whenever I can. That's why I like metrics, because they have decimals and it's like counting money. That one's fun. You're going to enjoy doing that. The other leaf might pose you a problem, because the other leaf might look like this. And what you have to do is actually measure the area in 4 squares. Now you might have one that covers 2 squares, something like that. So boys and girls, what we got to do is figure out on this square here, how much is covered by that part of the leaf. On this square here, how much is covered by that much of the leaf. On this square here, how much is covered by that much of the leaf. And on this square here, how much is covered by this much of the leaf. So boys and girls, what I'm going to do is I'm going to have you guys over here. I want you to figure out how much is in this square. I'll put a little X up there. Okay? You guys figure that out. I'll give you 4 right here. Do the other one on the top right. You know what I'm talking about? Top right. You 3 over here. Bottom right. Okay, this one over here.
no. Same as the one.
And then you guys in the back independently come up with the last one. Okay.
that one box.
So talk.
That's you.
All right. Here's how you're gonna play this game. The group over here, what was an answer we didn't like? In the general?
89. Like 80.
Oh, now hold on. You got to add these numbers up. So come up with a good number that you might want to add later on.
80, like 95.
Okay, I'm going to do this. For this first square here, 0.95. 95, 90.
Yeah.
Okay. What'd you guys come up with for your
95.
95 what?
I'd rather not do
Centimeter.
Cents.
Yeah, cents.
Or $0.90 or 0.90 centimeters. I'm going to leave the unit of measure out for now, just because we know it's going to be there. What'd you come up with?
95.
95? 0.95. What'd you guys come up with for this one?
50%.
How much?
50.
50? You think that's about half?
Yeah.
Yeah, it looks about half. And you guys in the back, what do you got?
23. 23. 23.
I want to write down 20 because I have to add these numbers up. Who wrote those numbers down already? Okay, write them down. Add them up. You wrote them down already, just pat yourself right on the back.
I said 89. Yeah, but that's what I meant. Everybody listens to you.
Is my addition correct?
Yes.
All right, look up here, please. That's how you're going to do yours. Exactly. So, boss, every child gets one leaf, and you're just going to pump it off right like this, so it kind of looks like a little heart shape. When you tape it down, this is a light leaf here. We're not going to measure the stem for the area, so you can tape it down, but don't count the stem. I have the dark plants. The boss is coming with the light plants. Did you already collect the tape, boss?
Yeah,
Okay, sorry. You should have it written out. Because we have a line going down, you could just put the measurement right at the bottom there, next to your no light or light. Eyes up. Boys and girls, the purpose question is, do plants need light to make a chlorophyll? And we said, the pizza method of measuring area, a large pizza, small pizza, which one has more cheese? Large pizza. Why? Larger. So, boys and girls, here's the question. Do plants need light to make chlorophyll? In your head, just come up with a one-sentence answer. All right, in your head. The question is, do plants need light to make chlorophyll? No, in your head means just put it in your head. Okay? How many people think plants need light to make chlorophyll? So, boys and girls, I'm going to call on one of you in 30 seconds. You're going to give me the awesome introductory first sentence in the paragraph that will answer the question, do plants need light to make chlorophyll? So start talking to the kid next to you. All right, time to play. Pick on a kid. Eeny, meeny, miny. No, hands down. I might pick on somebody who has no idea what they're supposed to be saying, which is really fun. Eeny, meeny, miny, mo. Catch a tiger by the toe. If he hollers, let him go. Eeny, meeny, miny, mo.
Yes, plants need light to make chlorophyll.
How many people think that's a good introductory sentence? Plants need light to make chlorophyll. Nice job. You said it a little differently with the word yes in the beginning. That's fine. Nice job. Now, who can give me the second sentence in a paragraph? Without a hand up or just you thinking? Oh, you know it. You know it. What is it?
Because it helps it to.
Now, how do you know? How do you know plants need light to make chlorophyll?
The chlorophyll needs light to make the green pigment.
How do you know? How do you know plants need light to make chlorophyll? What did you do today to prove that plants need light to make chlorophyll?
We measured the centimeter squared.
Ding. We group plants in light and plants no light. My results, the measurements, were, and then you can just write about what you measured with your little plants. Second paragraph would be this. First paragraph, plants in light to make chlorophyll. We group plants in light, plants in no light. My results showed that the plants going to light 10. What did I find out? Boys and girls, write this down. Plants need light to make chlorophyll. Number 10, write that down. That's the answer. We spent a month, no, right here, on number 10, right here. You could have written it down there, but on the worksheet's better. What do we find out? Plants need light to make chlorophyll. What?
Where's the question?
Look for number 10. We're writing down the analysis. What did I find out? What's the answer? What did I find out? Plants need light to make chlorophyll.
So I write this on.
Yes, you do. Now go back and look at your hypothesis. Front of the page, front page. First thing we wrote down was the question, do plants need light to make chlorophyll? Then you wrote down what you think was going to happen. Boys and girls, if you wrote down that you thought the plants are going to need light to make chlorophyll, then your hypothesis is correct. If you wrote down something else, that they would be tied, they'd have the same, or the light group would make more chlorophyll, then your hypothesis was what?
Incorrect.
Incorrect. So, go to the last thing on page 2. At the bottom, check off your hypothesis. Was it correct or incorrect? That. Now here's the thing. Some people go like, yay, I got it right. Ooh, ooh, ooh. That's okay, but here's the best thing. If your hypothesis is incorrect, I find that to be better. Because you go like this. Eyes up. It didn't work out the way you thought. You go like this. What? But the plant, green, pizza, and then you ask questions. And then you try to find out more about it. You learn more about something when your hypothesis is incorrect. Several times, I know you find this hard to believe, I've had a hypothesis that would be incorrect. And every time I was like this. What? Really? Huh? No. Why? Google. Figure it out.